This question is asking me what mass of which gas is left over. What mass in grams of which reagent, they're both gases, is left over? Okay, well, when something is left over, it means it still remains after the reaction is completed. And when I have two reagents, or reactants, if you wish, the one that still has some amount left when the reaction is complete was clearly there in excess to begin with. And the other one is the limiting reagent, because that's why the reaction stopped. It ran out. And so this question might also be worded, what mass in grams of what mass in grams is left over of the excess reagent, or which compound is present in excess and how much is left over at the end of the reaction. We would never ask you how much of the limiting reagent is left over at the end of the reaction. That would kind of be a trick question, because of course there isn't ever any, and by definition the limiting reagent goes to 0. So I need to figure out which one is the limiting reagent and therefore find out which is the excess and work with that. So we'll proceed in the order it's written. If hydrogen gas is the limiting reagent, then what mass of water would it produce? I'll convert from 12.2 grams of H2, and I know that 1 mole is 2.0158 grams, so that brings me to moles. And that's a balanced reaction, and in there I know that 2 moles of H2 react to make 2 moles of water. Okay, so I'll just do the calculator. So I've got 12.2 essentially divided by 2.0158. And that is 6.052. Not worried about sig figs, it's not a final answer. Right, so that's the maximum amount of water that could be made using 12.2 grams of hydrogen if I had excess O2. Now, if O2 is the limiting reagent, which would mean H2 would be present in excess, then it would stop the reaction when it runs out. So 154 grams of O2 converted to moles, 31.99888 grams of O2 in 1 mole. And I know that that's a 1 to 2, so 1 mole of O2 reacts to form 2 moles of H2O. Yes, I write it on the bottom so that they'll actually cancel, and I'll be left with essentially converted to the number of moles of water. Okay, what's this number on the calculator? 154 times 1 times 2 divided by 31.99888. And that is 9.625. I pick the smaller number of moles of product produced. This is smaller, therefore it must be H2 as the limiting reagent. Okay, so that means H2 will go to 0 and O2 will be left over. Question is how much? The only way I can determine how much oxygen is left over is I first have to figure out how much actually reacted. I'll take it away from the initial and I'll be left. So the last thing I'm going to do is a little calculation by difference. And so the mass in grams of O2 reacted, what is that? Well, that would be the amount in grams, the mass, that's needed to completely react with my limiting reagent total mass. And we just said that H2 is the limiting reagent, so it's going to not only determine exactly how much product water is formed, but also determine exactly how much O2 reacts. So it controls that too, and that's why I'm going to start again with the 12.2 grams of H2, convert it to moles again in my calculation. But now I want to convert moles of H2 to moles of O2, and I see that 2 moles, look at your balanced equation, 2 moles of H2 react with 1 mole of O2. That'll effectively convert it to moles, and now I want a mass. So 1 mole of O2 is 31.99888 grams of O2. So what's the mass of O2 that's reacted? 12.2 times 31.99888 divided by 2.0158 and divide again by 2. 96.83. So let's make it 96. Well, actually it's 96.8316. Okay, so let's do this. But it should only be 3 sig figs, so that's why I underline the 8. And so the mass of my excess reagent O2 remaining after reaction, or simply left over, that would be my initial mass, 154, minus the reacted mass, 96.832. It's all in grams. My number is still in my calculator at the moment, so I'll do that. I was going to make it negative and add to the original, but I can't find the sign. So 154 minus 96.832 is 57.168. Now, no decimal places, 3 decimal places. That means that my final answer can only have no decimal places. Therefore, the sig figs on it is 2. So my final answer is 57 grams of O2. That's what remains.